The blue whale is the largest animal that has ever existed. Nothing else comes close. It took 50 million years of evolution to build something this massive. 50 million years to reach 100 feet long. And yet, another animal pulled it off in less than 5. In 2020, an 11-year-old girl was walking along a beach in Somerset, England, and she found a bone. A jawbone. Just one piece of one jaw. And when scientists cut into that bone and looked at the growth layers packed inside, the layers were still wide open. No slowing down, no sign it was finished. At 82 feet long, this animal was still growing when it died. 82 feet. That's an 8-story building laid on its side. And it hadn't finished. It was still becoming something bigger. And we have no idea what that something was. There's a rule in biology that's been pretty much accepted for decades. If you're a predator, an animal that hunts and chases down its food one target at a time, you can only get so big. The energy you get from a single kill just can't keep up with the cost of powering a truly massive body. The only animals that figured out a way past that limit are the ones that stopped hunting altogether. Blue whales don't chase anything. They just open their mouths, swim forward, and swallow millions of tiny organisms in a single gulp. That approach, eating everything in your path instead of chasing one thing down, is the only strategy that lets you grow this large. A major study out of the Smithsonian confirmed it. Predators have a size ceiling. Filter feeders broke past it. And that was supposed to be the end of the conversation. Except then, an 11-year-old girl found a jawbone on a beach in Somerset. And it didn't belong to a filter feeder, it belonged to a predator. One that was actively hunting at 82 feet long and still growing, which means either the rule is wrong or this animal shouldn't have existed at all. So here's the question this video is actually asking. What did Ichthyotitan know that we didn't? What does an animal have to be, biologically, mechanically, at the level of bone and tissue to do something that the entire field of science said was impossible? And what does it mean that we almost missed it entirely? To understand that, you first have to understand what this animal actually was, because it was not what you're picturing. This wasn't some gentle giant cruising through the ocean with its mouth wide open, filtering tiny creatures out of the water like a blue whale does. The jawbone they pulled from that beach in Somerset has deep grooves carved into it. Those grooves are where muscles attached. Massive ones. This animal had teeth. It had eye sockets the size of dinner plates, built to see in total darkness thousands of feet below the surface, where sunlight doesn't reach. It didn't drift. It didn't filter. It chased down everything it ate, and it fought for every single calorie. And that's exactly where the problem starts. Now, I know a warm-blooded reptile sounds like it shouldn't be a thing, but scientists have cut into the bones of Ichthyosaurs, the group this animal belongs to, and found the same type of fast-growing, blood-rich bone tissue you'd find inside a mammal. The evidence is overwhelming. This animal, a reptile living 200 million years ago, was almost certainly running a warm-blooded body. So picture what that means at this scale. To keep a warm body going at 80+ tons, you need a staggering amount of food. To get that much food, you have to be fast, aggressive, constantly moving. But being fast and aggressive burns even more energy, which means you need even more food. Draw that as a circle. There is no exit point. The bigger it got, the more it needed. The more it needed, the harder it had to hunt. There's no slowing down. There's no coasting. It was basically a biological subscription service with no cancellation option. This animal was not living, it was burning. Which means the rule wasn't just broken, it was broken by something running an engine we didn't know was possible, and we found the evidence of it on a beach. The question is what else we walked past, and if the food supply dips even a little, the whole system doesn't wind down gently, it collapses. And here's the part that gets to me. The earliest known ancestor of this animal is something called Cartarhynchus, about 40 centimeters long, roughly the size of a house cat, with stubby little flippers that were, by all accounts, deeply uncertain about the whole swimming thing. That was around 248 million years ago. Within just a few million years, this lineage had already produced predators the length of school buses. And by 202 million years ago, Ichthyotitan was 82 feet long, warm-blooded, hunting in the deep ocean, and still growing. Whales took 50 million years to pull that off. This thing did it in a fraction of the time, from a house cat to the largest predator that ever existed. Every part of that should have been impossible, except it worked. For a few million years, it worked perfectly, which means the question isn't whether it could get this big, it's how anything alive could sustain it. But before we get to that, Bill, there's something else going on here that changes everything about how we think about this animal. For over 100 years, the textbook was simple. Reptiles are cold-blooded. End of story. Then, scientists started slicing into ichthyosaur bones and found something called fibrolamellar bone tissue. That's a mouthful, but all it means is fast-growing, blood-rich bone. The kind that's supposed to live inside mammals, not reptiles. Then it got stranger. A 180-million-year-old specimen of a related ichthyosaur called Stenopterygius was so well preserved that it still had skin. And underneath that skin, scientists found blubber, actual blubber, on a reptile. I mean, just sit with that for a second. A 200-million-year-old reptile with blubber. Then they tested the teeth. Oxygen levels locked inside the enamel told them this animal's body temperature sat between 35 and 39 degrees Celsius. That's as warm as you are right now. Dolphins have all those same features. Warm blood, blubber, streamlined bodies. Dolphins took 50 million years to get there. This lineage did it in a fraction of that. Now, back to that jawbone from Somerset. When scientists examined the growth layers inside the bone, they were completely open. No narrowing, no sign of slowing down. At 82 feet long, this animal had not stopped growing. It was either a juvenile or barely into adulthood. So the obvious question is, what did a fully grown one look like? In 1850, a set of bone fragments was pulled from a cliff near Bristol, just a few miles from where the jawbone turned up. Scientists looked at them and called them dinosaur bones. And for 150 years, that label stuck. Nobody questioned it. Let that sit for a second. The largest predator that has ever existed was lying in an English cliff, in public view, and the label on the box said dinosaur, not because the evidence was hidden, not because it was inaccessible, because nobody could conceive that the ocean had built something that large. We were that confident we already knew what was out there. Recent analysis now suggests those fragments didn't come from a dinosaur at all. They came from the jaw of something very similar to Ichthyotitan. And the scaling puts it at roughly 100 feet long. 100 feet. That's not a building on its side anymore. That's closer to a full city block. We weren't missing the evidence. We were misreading it. But here's the part that should sit with you the most. Of everything that has ever lived on this planet, we found the fossils of less than 1%. Marine animals are the worst. Bones dissolve, bodies scatter, and the deep ocean preserves almost nothing. From Ichthyotitan, we have 2 jawbones, a handful of fragments. That's it. And the thing is, those fragments turned up on a public beach, a place where families walk their dogs and kids skip rocks into the water. That's not some remote dig site in the middle of nowhere. That's a beach. And if 80-ton predators were common enough to wash up on English shorelines 200 million years ago, what else was out there that we've never found? What else lived and died and left behind nothing? The most unsettling part of this story isn't how big Ichthyotitan got, it's how confident we were that we'd know if something bigger existed. And that's not a gap in the fossil record, that's the fossil record working exactly as it always has. Every piece of evidence we find makes the original question harder, not easier. So what did it actually cost to be that animal, and what ended it? Now, the ichthyosaurs didn't just vanish at the end of the Triassic, and that's worth knowing. They actually survived. For another 110 million years after Ichthyotitan disappeared, there were still ichthyosaurs swimming in the ocean. But they weren't giants anymore. They were small, dolphin-sized, quick, built to run on less. They made it precisely because they stopped trying to be the biggest thing in the water. The strategy that built Ichthyotitan was the same strategy they had to abandon to stay alive. And what killed the giant wasn't some sudden disaster. Around 201 million years ago, a massive wave of volcanic eruptions flooded the atmosphere with carbon dioxide. The ocean absorbed it. The water slowly turned more acidic than it had been in hundreds of millions of years. Coral reefs collapsed. 96% of coral species gone. If you've ever seen a reef, picture 19 out of every 20 living things on it just disappearing. And with the reefs went the food web, the entire chain of life that an 80-ton predator needed to keep its engine running quietly fell apart over thousands of years. Ichthyotitan didn't die in an explosion. It starved. Slowly. While smaller animals survived by simply needing less. And that pattern didn't stop 200 million years ago. Ichthyotitan, a massive ancient whale that hunted other whales, disappeared when its prey shifted. Megalodon went the same way. Every time a predator lineage has pushed itself to the absolute maximum, the ending is the same. The bigger you are, the less room you have for anything to go wrong. And that rule hasn't expired. We can't know exactly how large Ichthyotitan grew. We have 2 jawbones, that's it. But that uncertainty isn't a gap in the argument, it is the argument. So what happens when the apex predator running that exact same logic is alive right now? And that brings me back to that beach in Somerset. Not the dig site, not the lab, the beach. Families walking their dogs, kids chasing waves, fossil hunters picking up rocks and putting most of them back. For over 200 years, people walked across that shoreline with no idea what was underneath them. The largest predator in the history of this planet wasn't buried in some unreachable trench at the bottom of the ocean. It was lying under a public beach. For 202 million years. The fossil record isn't a complete list of everything that ever lived. It's a crime scene, and most of the evidence dissolved a long time ago. We've pieced together the most powerful predator that ever existed from 2 jawbones and a handful of 19th century fragments that scientists spent decades calling dinosaur bones. And what little we found tells us this animal probably wasn't rare, which means the ocean once held something that broke every rule we thought we understood about life on this planet. And then, quietly, it erased almost every trace that it had ever been there. There's an animal alive right now running the exact same logic. That video is here. The blue whale was never the biggest. It was just the one the ocean let us find. The something else didn't get a name. It barely got a bone.